now we know how to find a cross product of two vectors. Keep in mind, the cross product gives us several types of things. We can find the area of a parallelogram by finding the magnitude of a cross product if those two vectors are the sides of a parallelogram. We can also find a vector that's orthogonal to the plane containing two vectors if we're just trying to find the cross product itself. So let's find the area of a triangle that has these vertices. So the point 0, 0, 0, 2, 3, 4, and 3, 2, 0. Now look at the two vectors that form the sides of this parallelogram. We're trying to find the area of the triangle, which is the blue shaded region. We can find the area of that parallelogram that's created by using those opposite sides with those vectors. And we know that the area of the parallelogram is twice what the area of that triangle would be. So let's find the cross product of the two vectors. Now we'll use OP, which is the vector starting at O and ending at P, and then we'll find the vector OQ, which will be starting at O and ending at Q. OP is the vector 2 minus 0, 3 minus 0, and 4 minus 0. And OQ is the vector 3 minus 0, 2 minus 0, and 0. That's pretty easy once you already know that one of the points is 0, 0, 0. Okay, so now let's find OP cross OQ. That cross product will give us actually a vector that's perpendicular to the plane, but its magnitude will be the area of that parallelogram. So we can get the magnitude once we get this vector and then take half of that. So the cross product, if you have two vectors in 3 space in R3, you put ijk in the first row, the first vector's components in the second row, and the second vector's components in the third row. We're going to do a cofactor expansion. We'll have I times the determinant with 3, 4, 2, 0. Remember, mark the row and column out that contain I, minus j times the determinant 2, 4, 3, 0, plus k times the determinant 2, 3, 3, 2. Evaluate the 2 by 2 determinants and we get 3 times 0 minus 2 times 4, I, minus j times 2 times 0 minus 3 times 4, plus k times the determinant 4 minus 9. So we have negative 8i plus 12j minus 5k. The magnitude of that vector, that cross product, is actually what will give us the area of that parallelogram. So it'll be the square root of 64 plus 144 plus 25. Which is 233. Or approximately 15.26. So half of that, so the area of the triangle, is the square root of 233 over 2. Okay. Now let's look at another application. Let's say we want to find a vector that's actually normal or orthogonal to two vectors. So we have the vector minus I plus 6k. So negative 1 down the x-axis, 0 down the y-axis, and k upward. We have v, which is given by 2i minus 5j minus 3k. And we want to find a vector that's orthogonal to those two. Now, u cross v will be pointing in this direction. If you look at curling, pointing your fingers down the direction of u and curling them toward v. So let's actually find what that vector is. The cross product is this vector. U cross v. Set up our determinant with I, j, k in the first row. -1, 0, 6, 2, -5, -3, which will be I times the determinant minus j times the determinant plus k times the determinant Now evaluate the 2 by 2 determinants. And we get 30i plus 9j plus 5k. Now this vector is orthogonal to both u and v. So a good way to check yourself is to actually find what is u dotted with u cross v. If they're orthogonal, that dot product better be 0. So u is -1 plus 0j plus 6k, and the dot product will be -30 plus 0 plus 30. Or let's take v dotted with u cross v. And we'll get 60 minus 45 minus 15. So we do have that they're orthogonal. It ends up any multiple of that vector. This vector here would also be orthogonal. Remember, a multiple is just a vector that's parallel, so it'd be pointing in the same or opposite direction. But that would be our cross product. And it's orthogonal to the 2 vectors that were given. Okay, now let's go back to torque again. The twisting that's generated by that force by R and F is perpendicular to the plane that contained them. The magnitude will just be the magnitude of R cross F. Which is just the magnitude of R times the magnitude of F times sine of theta, where theta is that angle that's between R and F. Now, let's suppose that you want to apply a force of 20 newtons to a wrench that's attached to a bolt in the direction perpendicular to the bolt. We want to determine which produces the most torque. Applying the force at an angle of 60 degrees on a wrench that's 1.15 meters long, or applying the force at an angle of 135 degrees on a wrench that's 0.25 meters long. In each case, we want to know the direction of the torque also. Now, the direction we know is going to be perpendicular to R and F. So let's just figure out the amount of that torque. The formula here, the amount of the torque is just going to be the cross product of R and F, which is given by the product, magnitude of R, magnitude of F times sine of theta. So we simply will be plugging numbers in. Our R's are the lengths of the wrenches. The force is 20. So in the first case, we have that the amount of the torque will be 0.15 times 20 times sine of 60 degrees. And in the second case, we'll have 0.25 times 20 times sine of 135. So we'll have 2.6 Newton meters for the first case. In the second one, we'll have 3.5 Newton meters. So we get the greatest torque by using the longer wrench and a larger angle. And in each case, the torque is orthogonal to R and F that's parallel to the shaft of that bolt.